All right. All right, we're close enough to on the hour, so I'll get this rolling. Welcome to Fighting Circle, folks. It's good to have all of you. For those of you who haven't met me before, my name is Reed McKenzie. Tonight I'll be presenting on tools, depths, and magic balls, as it were. This is my official plug that we're Funding Circle. We are making the world better with fintech and Clojure. So if you happen to be looking for opportunities, we happen to be hiring rather extensively in San Francisco right now. Come check us out. On that note, without further ado, kind of what's up? Well, I'm going to tell you a tale of two or more repos. We're going to talk a little bit about Clojure's tools.deps alpha library, go over some context on build systems, kind of what they are, what the history of these sort of things is, and I'm going to introduce Katamari, which is a thing I've been working on here and in some of my personal time. So, to keep this moving, the tale of two repos, right? Let's say I have a system, right? And this is a very traditional, monolithic architecture, multi-service architecture slide, right? In the beginning, when the world was young and we had big old mainframes, we would go write an application that ran on the same server as maybe its disk storage. It might have been vertically integrated with its storage mechanisms, and all of our queries kind of went through one box, right? And in the 2000s, as people started building quote unquote high scale web services, we discovered that, well, this one box is a bit of a bottleneck, right? And there was only so much traffic you put through this one box. And the way to have more traffic was to start breaking this box up, right? Have many components that talk to each other across network API boundaries with defined protocols. And it might be obvious to say, okay, well, each one of these services, service A, service B, service C, service D, service E, are all a project. They stand alone. They communicate across well-defined boundaries, and so we're just going to put each one in its own repo, right? And this sounds great until you wind up with this thing that we might all be familiar with, where you have a shared repo, C, and two dependent apps, A and B, that have to run the same version of C at all times, usually because C defines some shared business logic, say your serialization layer, right? You can't have two versions of your app that run, or two versions of your communicating application that run with mismatched serialization protocols. It won't work. So you wind up having lockstep releases between these two things. They may be decoupled. They may be extremely well decoupled in production, but at the code level, they are tightly coupled artifacts that cannot be decoupled because of this protocol requirement, right? And, this sucks. It's slow, right? You have, actually hand managing, go do the patch in C, then go release A and release B, is at least an hour of your life, let alone whatever time it takes to get this through CI, just in order to integration test the changes that you want to make to apps A and B, right? And that's assuming you have some staging environment where you can actually go test A and B at all, right? You can't test these things in CI before you get to that environment because they're not in a single place. There's no easy way to go make this change and kind of smoke test it, right? And so, when you have these not even poorly defined API boundaries, when you have API boundaries that don't give you decoupling, don't give you strong decoupling, you pretending you have decoupling by going multi-repo is just shooting yourself in the foot ergonomically, right? You're setting yourself up to take these coordination costs kind of where they are the most painful. So this is not to say decoupling is bad. Before anyone kind of hog ties me and carries me out here to be tarred and feathered, this is not to say design is bad. Right? These are both obviously good things and we want both of them. The problem is that they're hard and they're expensive, right? It takes time to come up with the right design. It takes time to come up with a decoupled design. It takes time to understand where your design can be decoupled from the things it needs to interact with. This is time that might not always be available to you, right? So either you can choose to decouple your things from the start or pretend to decouple your things from the start, because the reality is you as an engineer, we as engineers design these things. And we're in one headspace as we design both these things. We will make assumptions about how these things interact, how they could interact, that are based entirely on the fact that we are in a headspace, unless we're literally doing this across team boundaries, right? So, until CPARNAS 86, the rational design process, I highly recommend this paper goes over exactly this, the difficulty and the fundamental impossibility of gathering requirements and designing, but the necessity of pretending to do so anyway. Very good paper. But so multi-repos, or monorepos rather, solve this problem, sort of, right? They're an ergonomic optimization. The thing that you admit by going monorepo is you admit that you have all these things that are coordinated, that need to be coordinated, and that you can succeed in coordinating them precisely by having exactly one point of lockstepping in your entire system. It's the Shah of Git master, right? Everything, any change in your system goes through Git master. If you want to hold up a change, you just prevent the merge. If you want to coordinate a change, you just do one merge that brings a whole bunch of stuff in at once, right? You want to test a branch. Well, you test a branch where you test every component in the system at that branch, so you can test all your things patched against each other as they are in the branch, and then when you merge it, it all happens at once. This is assuming a reasonable modern CI/CD pipeline. That's a fundamental prerequisite for this contention, right? Note that I'm making a very particular claim here. Monorepos are an ergonomic optimization over the coordination costs of multi-repo, assuming that you have not successfully achieved the decoupling necessary to work in a multi-repo fashion. Okay? Everyone good? Awesome. So what does appropriate investment mean? Appropriate investment means you have to have a thing that does change detection. You can't have 1,000 modules in one repo and only change one of them and rerun the tests for the other 999. That will not scale. If you do that, you are imposing upon every one of your developers the linear cost of every other module's tests in the entire system. The costs of making changes in the monorepo have to scale linearly with the impact of the change you're making, or at least with the dependency tree cardinality of the change you're making. They cannot scale with the cardinality of the repo. Otherwise, you've just completely failed, right? For extra credit, incremental parallel test running and shared test deploy pipelines would be nice. Those turn out to be very easy to get once you get into monorepo configuration, but they're not as critical as the fundamental need of not imposing upon your developers a cycle time, a CI time that grows with the size of the repo. And there's a lot of art for this, prior art. Google has Blaze, which was open sourced as Bazel. Facebook has Buck, Twitter has Pants. In Clojure, there's a couple different systems that try to do this as well. There's Line Modules by Jim Crosley. There's Amperity's Line Monolith. With tools.deps, which I'll talk about a little bit more in a minute, you can sort of hack some of this up using the local root behavior. You could obviously fall back to Maven and go make good old Maven multi-modules. And supposedly you could pull this off with Gradle as well. I'm not a Gradle expert, so I haven't tried this. But I laid down some criteria for appropriate investment here, right? Where I said that testing and retest minimality was absolutely central to its workflow working at all. So let's kind of run down the matrix here. What do we have? So Pants does incremental builds and incremental tests, but it doesn't support Clojure. Turns out that building Clojure support into Pants is a pain because Pants has a bunch of specific assumptions about Java-C and the behavior of things that need to interact with JVM class paths, because the thing that Twitter EE cares about is optimizing Scala compile time. That is the only thing that entire pipeline of code cares about, is making Scala-C fast. Everything else can go to heck. Sorry? Less slow. So this turns out to not work. Bazel has similar concerns. Bazel has to make Java-C and Scala-C fast. It's a giant tangle of code. You could, in theory, go bolt a Clojure front end onto it, but it turns out to be non-trivial. Buck, same set of problems at the end of the day. There is an attempt out there to go write a static analyzer for Clojure that becomes an implicit Buck dependency tree importer thing. I've never gotten it to work. And again, Buck is a fairly complex system developed by Facebook with not fantastic documentation of how you go extend it. So, these are all amazing high quality build systems that solve their particular set of problems really well that are utterly useless for anybody else's problem. Line modules is not incremental. It just goes over all your modules in topological order. Gives you no tools for detecting change, using only things on the changes, so that doesn't solve the minimality constraint at all, and that makes it a non-starter, even though we use it. Line Monolith, I don't think it has incremental capabilities. I can't really tell, to be honest. Gradle might be incremental if you hack it yourself. I can't tell, again. And Boot definitely was never designed for incremental. Well, it is incremental, but it was never designed for multi-module. And so building like incremental multi-module behavior into boot is like as much of a software development as just building a build system yourself, seemingly. You might ask Sheen Cornfield about this. He supposedly had a multi-module boot system. Sean Cornfield, thank you. But supposedly his company just threw that out in favor of a DEPS-based thing. So that speaks, I assume, for how well it worked. So, you know, to kind of cover my bases here, I said that we were doing line modules. And I don't expect you to read this, but this is some really horrendous bash that I kludged together in like the last 3 months that implements minimal or like pseudo-minimal retesting using git log and grep and awk to figure out what modules in the multi-repo have changed and only run tests on things that are topologically below things that changed. It works, okay? This chopped our CI times down 50 to 30%, so it was worth the effort to go hack all this together. But this ain't a build system. This is a Franken build at best. More on that word in a minute. And so, you know, to kind of cherry pick a mean case of my own personal build, this is bumping a version in my build as of about a month ago. 20 minutes end to end, about 120 minutes of computer wall clock time to actually like build and integration test and smoke test and lint and everything else, a single bump in a transitively dependent repo that strictly added code. Okay, this is insane. Have to find a way to do better than this. On an 8-person team, if I have 8 engineers that push like 6 or 8 builds a day, any single one of which burns 20 to 40 minutes of wall clock time, depending on how pathological the build is, you know, going through this is just unacceptable. It is wasting developer time, and this needs to be fixed. So enter Clojure's tools.deps alpha library. About a year ago, Rich and Alex open sourced the CLJ and Clojure scripts, collectively known as Clojure tools. Clojure tools are aimed at solving the particular problem of building class paths. Rich has a really good snippet from his recent Datomic Ions talk. I'll share the slides later. I have a link to it in this slide, in which he says, I want a thing that solves one problem, and that problem is building class paths, right? Rich's argument is that for Clojure, for the most part, you don't actually need to do a full build. What you need to do is build a class path. And most build systems have several things kind of rolled together, right? They have a plugins framework, they have a dependency resolution engine, they have like all these things that kind of get sucked into the big ball of mud that is collectively called the build system, and you can start untangling. And so what the tools.deps library does is it gives you a way to, nope, not the slide yet. Sorry. And so what the tools.deps library does is it gives you a way to consume these deps maps and options and profiles and use them to build both class paths and JVM invocations so that you can, in a kind of consistent, repeatable fashion, rapidly build your class paths or rapidly determine you can hit in a cache for a class path that hasn't changed. The assumption being that your inputs change slowly relative to your code, and that, you know, just recycling class paths with that happen to have changed code on them is the thing you want to optimize for, which is mostly correct. You know, as I said, you know, Rich said it himself, I really want a thing that only does deps, right? Turns out this is not the problem that I have. Like getting deps, finding things on a Maven repository is not a hard problem. We've been able to do this since we've had, as long as we've had Maven, right? And even before that. So what I actually need to solve in order to fix the problem that is my build pipeline's time, I need to solve packaging, I need to solve deployment, and I need to solve testing. None of these things are solved by deps, unfortunately. We made an attempt, Ein, which is open source. You can go check out Ein. It runs on top of a very heavily patched copy of the, or not even heavily patched, a fairly lightly patched, in fact, copy of the Clojure script, the CLJ script. Turns out that the CLJ script is incredibly good. It's very well written bash. It solves exactly the problem it's out to solve. It solves it well. It just doesn't solve my problem. So what Ein attempted to do is Ein attempted to take the Clojure tool and wrap it directly in a bash script that made it behave sort of like Linigan. We were trying to find a way to get a multi-module, multi-repo, multi-class path shared configuration behavior out of the Clojure tool. And we sort of succeeded, except that, well, it was Circle CI build time regression. So the like time boxed spike in which I went and built Ein came back with what was ultimately a completely fatal result. It was not obvious that I was going to be able to take this thing and get it to build class paths and run tests in the time constraints that I needed to be able to beat my current Lineage-based workflow. I spent a bunch of time with your kit profiling what it was that was happening in the JVMs and what I was having startup times, and the conclusion I came to was booting JVMs and booting Clojure and class loading Maven to only throw these VMs away again is a complete waste of everybody's time. There's no way to make it faster. And we needed to be doing something amortized VM startup. There's also some other stuff. There's tools.deps 79, which Alex is supposedly working on right now. I have a patch for it that has limitations to it, but it's applied in Katamari, and more on that later. And it results in pathological behavior in the tools.deps resolver when you have either shared deps. So let's say everything in your repo depends on some library at some version. This means that every single time tools.deps looks to resolve the transitive dependencies of a given module, it will re-resolve that shared thing, which for my repo resulted in over 3,000 or 4,000 re-resolutions of single artifacts. So I was seeing tools.deps resolve class path build times in like the 90-second range using tools.deps versus the 7-second range in Lineage, entirely because of this bug. Also, if you have circular dependencies, it doesn't work at all because it equates to a naive depth-first traversal of the dependency tree with no deduplication or cutoff, so it just goes forever. Also, there's no obvious pattern using tools.deps for building change detection. Change detection is the thing I care about, right? Nothing else matters to me. I need to be able to get to change detection. And there was no obvious pattern for taking a thing that used tools.deps to build a class path and getting from that thing, because that works great, in fact. I don't have to go build that, I just pull it off the shelf, to a thing that built other modules recursively. So, there needed to be something else here. Mercifully, Simon Peyton Jones kind of came to my rescue. Good old SPJ, I don't need to do any work, just read some very smart people writing some very eloquent stuff. There's a paper, Build Systems a la carte, was presented at ICFP this year, that kind of breaks down what the elements of a real build system are. That it's an absolutely gorgeous paper and a fantastic talk. I cannot recommend it highly enough. But so the first thing that the talk does, it lays out these 4 properties that you might care about in your build system. The first one is minimality, which I've kind of already been harping on this entire time, right? Minimality is just the property that if something changes, you only rebuild things that depend on the thing that changed, right? So in this case, if you rebuild util.h, you have to rebuild the entire tree because everything depends transitively on util.h. Here, if you rebuild main.c, you can recycle the previously built util.o because it hasn't changed, but you still have to go rebuild main.c, right? Early cutoff is another interesting property. Early cutoff means that if you can detect that you rebuilt a thing you previously built, you stop there. You don't have to go rebuild anything that depends on the thing you happen to rebuild. Okay, so here, if I change a comment line in main.c, I will rebuild the same main.o, assuming that I have a non-completely trivial compiler, which means that I can recognize the fingerprint of main.o hasn't changed, and I can skip rebuilding main.exe because main.exe depends on main.o, which hasn't changed, in effect. Another one is it does, but it does, but that is a fundamental assumption underlying most of what I'm talking about here today. Why is my slide deck freezing? There we go. Okay, cloud build. Cloud build is another interesting one. Cloud build is the realization that, okay, well, if you've early cutoff, you can just start downloading stuff. You don't even need to go figure out that things haven't changed. If you can detect that they haven't changed, you have a fingerprint for the thing you think you want, or you can predict a fingerprint for the thing you think you want. You can just go pull it off a shared FTP cache, right? There's no reason for everybody in the company to go rebuild the biggest shared libc you've ever seen in your life all day, every day. If you can just build it once on a big old build box and re-download it, or let everyone else re-download it. And the final one is dynamic dependencies. Dynamic dependencies mean, is any given rule, every given production rule in your build graph, able to dynamically change its dependees, so what it depends on, based on inputs. So here, if I have a file release.txt, which is a sequence of lines, each of which names another file in the file system. Originally, that was just bins.txt, right? Some list of things to go slurp into a release tar. If I go add the line docs.txt, now the README is a dependency of release.tar, even though nothing in the file system has changed, but releases.txt, because of the fact that releases.tar is a dynamic build product that it works by inspecting the releases.txt file. Does that make sense? So let's loop back let's loop this back to my build, just to kind of recycle the thing. It's a Franken build, right? It's a build that's built by cobbling together multiple build systems. That's the definition of Franken build given the paper. It's a non-minimal build because it rebuilds everything. It has no cutoff. It has limited wins at best from cloud caching, despite a fairly heroic effort to leverage Circle CI. And it has no support for it sort of has support for dynamic dependencies because Line's plugins give you a way to achieve dynamic dependencies, but it's a very limited form of dynamic dependency that we don't actually do anything we need with. So the conclusion of the paper, which is a very interesting one, is that there are two axes you can really use to classify almost every build system out there right now. The vertical axis here is the invalidation rule. How do we decide that a build rule, the build input has changed? The horizontal axis is what's the scheduling algorithm for what we go build and in what order we build it. So for instance, you have topological builds. This is your traditional make, right? You have static dependency enumeration, and you just go in topological order over the things that you need to rebuild. You have restarting builds. This is something like Microsoft Excel, which turns out to be a build system when you squint at it enough. The restarting algorithm is you start building something, and when you detect that it needs something else, you go suspend the current thing and build the other thing and restart. Or you just detect that you have an unbuilt dependency, restart the build, and keep running the whole build until you reach a fixed point. The two are equivalent. The final one is suspending, where you actually have the special case of you dynamically inspect the dependencies of every rule, so you can go get dynamic dependencies, and then you go build that and suspend the current thing and come back only when the thing that it needs has been built. So there are trade-offs here, right? With a topological system, you cannot have dynamic dependencies. It is impossible. You must be able to do static dependency enumeration in order to build in topological order. With a restarting system, you will not be minimal. You will redo work. There's a proof of this. With the suspending system, you can't have cloud builds for a variety of reasons. And with a suspending system that uses content-based addressing of the things that it takes as inputs, have early cutoff. Because if you have upstream change, the trivial fingerprinting of the upstream things based on the construction trace to get to it always change. So you can never find a truncation point in your dependency tree. There's a magical empty space here. And one of the things that comes out of this paper is that nobody's ever built a thing that does all of these at the same time. It would be cool if we could. And so SPJ presents what that thing would be and what the combination of algorithms would be to get you there. But build systems are hard. Just building one of these things is a massive engineering effort. And in all the years of building these things, no one's ever realized that you can combine the properties in the way such that you can kind of get most nice behavior at once. Katamari doesn't do this, by the way. Just it's a point in the design space that exists. So I've kind of beaten around the bush here. I mentioned Ein, I've mentioned tools.deps, I've mentioned line modules and line again itself. It's time to kind of go unveil Katamari. Katamari is nicknamed after Katamari Damacy. It's a PS2 game, fine, in which you are the prince, the son of the king of all cosmos, and you run around this magic ball, rolling up all the things in the earth, and the mission is to go assemble the biggest ball of crud that you possibly can in a given time window. Which is appropriate, right? We're going to take our software and kind of roll it up into a giant ball of crap and then go deploy it somewhere and pray it works. Or hopefully not a ball of crap, but that's at least the degenerate case, the first thing we need to work before we can go solve all of our other problems. And so the design goals for Katamari is first and foremost, minimality, kind of the same thing I've been harping on this entire time. I need rebuilds to be fast. And I need change detection to be fast so that I can go optimize a CI pipeline, make sure my coworkers aren't wasting their time, help them have better development cycles through having faster feedback, through having confidence that the changes they make to their source trees are appearing in the code that they're testing. And really, I just want to try and start zeroing out this overhead cost, the ergonomic costs of running in a multi-module configuration, as opposed to multi-repo configuration. Because right now there is reasonable, significant resistance internally to running in this sort of God repo, because the ergonomic costs are not optimized. So to kind of loop this back to the SPJ paper, this is the design space I'm shooting for. I'm shooting for a build system that uses constructive fingerprinting traces and consequently could support cloud builds in some forms, but is topological at the end of the day. We're going to talk, there's some capability for dynamic behavior here. Right now it's not leveraged. that is an outstanding bug I will talk about later when I go into the limitations of Katamari. Non-goals. Cutoff would be nice, but proving that equivalence is hard, and for the most part, the things we're building are really cheap. They're just like class path entries, so cutoff is an over-optimization here, as far as I'm concerned. Cloud product caching, again, would be nice, but again, the primary thing I'm building here is the class path, or at least class paths, so it's just not worth the effort to like be curling class paths off a cache server. It's a massive amount of complexity for probably a negative performance win. Dynamic dependencies, again, would be nice. I do want to have some limited forms of dynamic dependencies eventually, but they're not a thing that's essential for my current use cases, and so we're punting on that. And I'm only going to try and be compatible with line or boot or even tools.deps itself if it is absolutely trivial to do so and to do so correctly. I'm not going to go rebuild like boot's evaluation system or Linigan's full middleware plugin system because they're just giant balls of mud, and why would you? So what is Katamari? Well, I mentioned earlier that I needed a way to amortize JVM startup times across multiple uses of the tool. And it turns out that if you do that, that building class paths comes down from being order of like 15 or 30 seconds to being order of 7 milliseconds. Just because you are reusing a JVM where all the classes are already loaded and the actual amount of time that is spent computing the class path is utterly de minimis compared to the amount of time that tools.deps spends just booting the JVM in the first place. So Katamari consists of two programs, a 200-line bash script that uses awk, JQ, and curl to talk to a Java server. And the Java server then does all the actually interesting stuff. It has an extensions API that implements command line tasks on the server side and has a protocol for communicating command line interactions back to the client. And particularly, that extensions API is able to require arbitrary user code. So all of Katamari is actually dog-fooded on top of this API based on just having an extension interfaces with the compilation system. The compilation system, well, the extensions pattern that the compilation system uses is derived directly from Clojure tools.deps extension system. It is actually very good. It's been a pleasure to work with. I've only had to patch it a tiny bit. The basic pattern is you have a namespace called extensions that has a multi-method API. And you have a bunch of other stuff under that same extensions package that is not required by anything else, that you rely on the user to load as the user wants it, that extends that multi-method API with appropriate behavior conforming to the contract. That's it. There's kind of nothing else more to explain here. Katamari internally has 2 of these. There's an extensions API inside the compilation pipeline, and there's an extensions API for writing server tasks. And one of which is, of course, the task that uses the compilation pipeline. Then there's some others that use tools.deps extension API to enable tools.deps to build class paths using build products the way Katamari understands them. Click. Yes, no, maybe. There we go. So what's an example repo look like? Oh man, this slide got lunged. Sorry. An example of a Katamari repo would be you have the Katamari script itself. It just sits in your repo. The intent of Katamari is that, like pants, you can vendor it. You must be able to include Katamari at some source version in your repo and patch it to suit your needs. That's more important than having Katamari be like a stable, deployed, common, and shared thing that solves everybody's problem. Your problem is different from my problem. That needs to be reflected in that you can patch this thing and vendor it and run it yourself. I'm not going to try and solve everybody's use case. I will, however, empower you to solve your own use case. Katamari has some supporting files that it needs, which are bootstrapped if you just pull the latest cat script and run it. There's the cat.conf file, which says how to start the server, what the extensions the server needs to go code load, how the client talks to the server, all of the good important stuff like that, all of which is parameterized and tunable. Then there's some dependency defaults files. I'll get into those more later. And then you have a source tree, right? So in this case, I have a package called example. The choice of the name example is meaningless. That source tree could be anywhere. And it has a role file. The role file declares what build targets exist under this source tree. The naming of the targets in the role file is arbitrary. So let's look at the role file. In this case, I have a role file that says def target. Def target example Java-C is a Java library. This is called a manifest. More on that in a second. And it has parameters. So in this case, it's the paths source main Java. Right, so we go back a slide. You can see that there is in fact a Java tree that has the package demo and the class file and the Java file Java or demo.java. There's also a Clojure package, right? That's a Clojure manifest and says it has these source paths that are in the Clojure tree, and it has deps. This is just a tools.deps dep map. More on this in a second. Finally, we have, two products. We have a simple jar that depends directly on the Java C and CLJ targets, right? So even though this is a deps map, these will be resolved against the role file defined targets. And finally, we have an Uber jar that, again, just depends transitively on the other stuff, right? And these are jars and Uber jars as you expect them. The jar is a simple thin jar that only includes direct dependees. The Uber jar rolls everything up. And so it's a jar that will contain all of its transit dependees as well. So I mentioned the word manifest, right? Manifests are the keywords by which Katamari associates a build rule with the behavior you want to use for it. Role files are not evaluated. They are not full programs. They are a spec parsed DSL with a very specific structure that is intended only to let you parameterize role files or parameterize role targets. The only supported form is this def target, and the only supported forms within a def target is a single rule manifest. Rule manifests are defined through the rolling extension API. More on that in a second. So this is not going to be legible. It's not supposed to be legible. It's just supposed to demonstrate that it exists. When you parse all the role files in a project, which you do every time, first off, you can do so incrementally. You only have to reparse role files that have change, right? If the modified time has changed and or the content hash has changed, then you have to reparse the role file. The rest of the build graph remains valid. There's no macros or anything else here that would lead to the role file having transitive invalidation or lead to transitive invalidation behavior in the build graph. And the build graph actually happens as a diff structure at the bottom that says precisely what changed and where and what rules were invalidated, so you can go do the change detection I've been on about this entire time, at least the build rule level. So what does it take to actually go compile this stuff? Well, this is kind of the guts of the compilation pipeline. I'm not going to show the code for this because it's not a lot. It's actually quite simple, but it's beyond the scope of this presentation. Rolling happens in a couple steps. The first one, obviously, is just parsing all the role files. This builds the graph that you need to compile. The second one is you run prep tasks. Every manifest has the opportunity to prepare itself. The prep tasks for manifests are run in no guaranteed order. Each manifest has the opportunity to perform arbitrary computation on both the build's config and the role graph itself. So a manifest could choose to inject another manifest, another role target, whatever it needs to do to set itself up for a shared compilation process. Individual targets as well have the opportunity to go generate other sub-targets or other configuration into the graph. All of this runs in a fixed point operation. Finally, once we've done all the config and the configs have fixed, we assume that they fix. If you build extensions that don't fix, that's your problem, not mine. I'm not merging it. We go and we ask the rules what their inputs are. This is the classic topological build order constraint. The inputs are the way that, or enumerating inputs, is the way that a rule explains as keyword arguments what it expects to get when you try and compile it. This both solves the problem of transitive dependency enumeration or direct dependency enumeration, and it also and the problem of how the rule, when you say build me, gets its inputs if it has multiple inputs of different kinds. So if you wanted to say, I'm going to have this set of dependencies that will be my compilation time dependencies, and this set of dependencies that will be my runtime dependencies, or even worse, this set of dependencies that will be my Java C plugin dependencies when I do my compilation, in addition to my class path dependencies, when I do my compilation, and then my runtime dependencies, all of that falls under this input partitioning scheme. Once you have all the inputs, you go top sort them. Inputs are just references of other entries in the build graph. If you give me if you return something in your input enumeration that's not in the build graph, it's an error. And then given that input ordering, we build a topological, we build a topological order and just walk through it. So given every rule's inputs, we can call this function rule ID. Looks like I typoed the slide here. Rule ID takes all the parameters that you will pass to rule build, but it returns a fingerprint. It is a content hashing operation, not a building operation, and it must be constant time, and it's expected to be drastically cheaper than doing your build. Must be repeatable based on your inputs. There's a bug here in a second. Finally, there's build, which actually takes your inputs and does the work and gives you a build product. So the design here is, again, we need this content hashing or like lazy reuse thing where if your fingerprint, if the rule ID is something we've previously built, we don't have to go rebuild anything because we just hit in the cache, we see that the build product already exists, grab it and keep going. So, if you haven't changed your Java source files, we just reuse all the class files. And we just do that until you finally get an output matrix, which is just a map from rule names to computed build products for all built products in the entire graph. That's it. So as an example of a manifest, since I mentioned manifests, this is the actual implementation of the Clojure library build manifest. All it does, it takes the default implementation of rule ID, because the default implementation of rule ID is pretty good. You shouldn't change it unless you really know what you're doing. It has no prep for either the rule prep or the task prep. By default, they do nothing. I just include the rule prep here to show that it does nothing. And for inputs, it says, okay, well, I'm going to take the targets out of the build graph, the targets being the actual map of target name to rule. And I'm going to go through my deps, and I'm only going to return things in my deps that are also in the targets list, right? So your Java, your Clojure library doesn't depend on any of its Maven dependencies in the build graph, because none of its Maven dependencies exist in the build graph right now. But it does depend on all of your source dependencies that are in the build graph. So that's what this captures. And then we actually run the thing. You get the config, the build graph, the target, the rule, the products, the inputs you actually asked for. The product is everything that's been built to date. And you just go call out and you say, dear extensions API, JVM plugin, go make me a class path given the same config, all the products and the deps that I asked for. This gives you back, this is just a direct wrapper around tools.deps make class path function, just calls the same code under the hood, no changes to the API made it there, works great. And you get back a class path in the lib map. And so all you produce is a product that says, well, I have the paths of my rule and the depths of my rule, and also like maybe you pull the class path and lib map through, even though they aren't transitively useful products. Everybody tracking? Yes, no, maybe? Seeing some nods, okay. And this is the implementation of actually like calling out to tools.deps. It's a little bit more involved. But fundamentally all we're doing here is we're saying we're going to have a magical alias called role that's going to contain all of our default resolution options merged together properly. So this is that deps default profiles and deps default or deps resolve defaults file that you saw at the top of the repo earlier. This just gives you a way to say, for everything in this repo, here are the Maven resolvers I want to use. For everything in this repo, here are version pinnings I want to use. Just share them across all the resolution that happens in the entire repository. And you also bolt on a construction that looks like a deps mapping that just tells deps how to go build class paths for things that were in your role graph. So for all the inputs you've already built, here are their paths so that you can go build a combined class path that includes all the paths of the things you depend on transitively that were source builds. Does that make sense? Okay. And you just call, tools deps create class path with the merged up mapping. That's it. It worked fantastically. So demo. Let's actually try and do this thing live. We'll have to change my screen share settings here. So I've got a repo that's visible on screen. And it's got kind of nothing in it right now. It's just got the same sort of demo tree that I had a screenshot of earlier on my slides. So I'm going to go hop on GitHub and stop this. Come on, where'd you go? So I'm just going to go hop on GitHub and go browse over to the releases list of Katamari and grab the latest one. Yeah, I know. Sorry about that. So we're just going to go, pull the latest cat script, and it's there. And we're going to, so cat total executable, and this will say, what are you doing here? Just going to nuke all my Java processes because I had a previous cat instance floating around. I didn't want to talk to it. So start the cat server. it is currently rebootstrapping itself off of GitHub at the latest deployed version. None of this is, like, all of this is just baked into the script. You don't have to do anything, you just curl it down and away it goes. Looks like there might still be some bugs in it. PR is welcome. Sorry? Oh, I mean, starting server, waiting for it to become responsive. It's a reasonable one too. Okay, cool. So we have a server. So what do we have? Looks like we have a whole bunch of tasks here. Katamari says, here's my usage. I have some flags that happen at the script level, and there's some commands that happen at the actual server level. So there's a way to clean the cache. It's a way to like actually do a compile of targets. This help thing, which is actually what we're seeing now. You know, this list targets thing that we'll use in a second here. List tasks. You know, kind of on down the list. And critically, there's like stop server and a way to nuke the cache. So cat clean cache 0, just to show it's empty. Cat list targets. So these are all the targets that Katamari knows about in the role graph for the current repo, right? The repo only consists of the one role file. This graph was generated while, this result is processed by inspecting the result of parsing all the role files, which happens as a precondition of processing the request that I just typed in. There's a cache that makes this an incremental operation. So every time you hit the cat server, it reparses all the role files, and away you go. And so we're going to say cat compile example / Javac. So I don't have incremental standard out plumbing to bring what the server is printing back to the client yet because of the way that the response protocol works. But here we can see that we went and we built this example Javac target, and we have this path that's in my current working directory and the .cat.d directory, which is the configured working directory per the cat.conf file at the build cache subtree, and it's, you know, some cache entry / target. So what's in there? Oh, and we see that there's this ID 0672. This is the fingerprint of this build product. You can see that again in the cache key. So what's there? Sorry? That fingerprint is it's a GUID derived from the hash of a bunch of stuff. And so if we look at that cache key in our just treeing it, we see that it's got the demo package and the one Java and the one demo.class file in there. We can actually go like Java p-c it or something, but we're just gonna keep going for now. So what if we, cat compile example / CLJ, right? This is a slightly more interesting one. If we look at this, we see, okay, well, we reused the JVM product at the same ID. There was no work to be done. We just, we got the same cache entry. There was nothing done there. We just went and built the Clojure target, but the Clojure target doesn't do anything. It just gives you the paths for the target and, helps you wire up the transit dependencies. And so we have a cache ID that's kind of useless, and that's it. There have been variations on Katamari where the actual class path for that given target is a product in the build graph. I'll probably bring that back in short order, but for the most part, it's a useless product because you can't merge class paths from transitive dependencies. You have to re-resolve dependencies given the changed graph. So it's just an incremental product that's kind of trash. So if we go compile the jar that contains all these things, we're going to roll up our first smallest ball of things here. We see that, okay, cool, the JVM product got reused the same ID, and cool, the CLJ target got reused at what I presume is the same ID, so 0 Bravo 45, 0 Bravo 45. Okay, so we successfully reused both our build products, and we got a jar, right? So if we actually go, how can I do this? Go edit the jar with Emacs. Stop share. Let me just go to my whole screen here. We see that, there's our demo.class and our demo.clj in the jar like we'd expect. And, the file modification times are ish. Yeah, no, they're now, which is what we expect because we just splatted all this stuff in. Cool, so let's go back here. The last thing we're gonna try and do is we're going to build the Uber jar. So the Uber jar is going to take a little bit longer because it has to go grab Clojure and copy all the stuff out of the Clojure jar into the other jar. But we still get it. But it's still pretty right. But it's still pretty fast. And so we get back a jar. And so now we can say Java CP. And amusingly, so you can see I have the auto completion here from the previous time I did this demo. You can actually see that the cache key for this Uber jar 0 Charlie Fox, 0 Charlie Fox hasn't even changed between having completely blown away my Katamari like the entire Katamari install, all the config, all the everything, and redone it. So I'm just going to hit Command Space to pull it off, and this is going to go boot Clojure and run my demo. And we hit the Clojure main, which delegated the Java main and the Java compiled class, both of which got no args. So all the code ran, and ta-da! Yeah. Sorry. No Emacs?
No Emacs.
No, and no Emacs in that jar. I was really tempted to do the demo where I actually source compiled Clojure itself, and then Uber jarred up the source compiled Clojure with my stuff just to prove that if I really wanted to, I could have a copy of Katamari that was bootstrapped on a patched version of Clojure and would rebootstrap itself. The big milestone for me with Katamari was about a week ago. I succeeded in getting a version of Katamari that was self-bootstrapping. And so Katamari has been self-hosting and self-redeploying for about the last week, 2 weeks.
If you run the Uber jar, compile Uber jar, again.
Yeah.
Instant?
Sorry? Yeah. Yeah. Bam.
Yeah.
Same fingerprint. Sorry, I took that one for granted a little bit too much there. I understand that's not what anything else does. Yeah, no, that was the whole point of the freaking thing.
Now, what about your mono repo a bunch of stuff?
I don't have a demo that does that. Katamari itself right now is the biggest Katamari repo that does multi-module, and it's a poor example of multi-module because all the modules are dependent on by Katamari. Go figure. So the rebuilds there are never minimal in any sense because you always have to go blow away everything and rebuild Katamari. That's the point. So I think the Katamari repo itself has Katamari. It has Clojure tool, is a patched copy of Clojure tools, is a patched copy of tools.deps alpha because I have a patch for the tools.deps 74 bug that I mentioned. It's one that's been upstreamed. It's one that Alex has said he has some quibbles with. So whatever. And yeah, that works. I haven't tried it for my real repo yet. Let me actually get to my slide where I talk about limitations of this thing. Oh, looks like I killed my presentation entirely, so I'll just let it go. Yes, you have to maintain them. You have to maintain them yourselves. Yes, yeah, it's intentionally like make.
In the role files, I noticed you had some namespaced functions like fs/. Where is the require?
Oh, that's not in the role file. That's in the implementation of the targets. And that's just because I screenshotted off the essential part of the code, not the namespace declaration, because slides are small and code is smaller. Yes?
You pass in a config to a bunch of stuff in the role file, I
yes.
think, and what's in that?
Oh, thank you. I forgot to mention this. So one of the things that Katamari...
I'm not a plant.
So one of the things that Katamari does that I'm really proud of is it is almost completely stateless. All of Katamari's state comes from a config object that gets passed in from the cat client every single time you make a request. So if you actually go, let's go pop up Vim. Please don't shoot me. Sort of. So the way that Katamari actually works under the hood is it literally just curls the backing server. And it does so, come on, where are you? Here you go, with this god-awful JSON blob that basically tells the server all the shell environment context that the CLI client is being used in. And so when the server handles a request, all it does is it takes the config it was booted with, it takes the config that the user's client figured out it needs to be using, and it operates as if it were in the user's repo. So you can actually have a single Katamari instance that's fully shared across all your projects on your entire frickin' computer. You could even, I suppose, find a way to do a remote Katamari if you really tried pretty hard. But yes. The server right now does have to be on the same computer. There's not enough real RPC layer there to go bidirectionally. That may yet change, but you know, where do I want to spend a complexity budget? I think that like you already run like Docker and all these other things on your server, on your local dev box, asking you to run one more lightweight jar that really doesn't do much and certainly maintains no meaningful state shouldn't be that onerous. Certainly compared to like booting Lion all the time. So that's the cat script. Yeah, exactly. It is heavily inspired by Grenchman, in fact. So Grenchman, for those of you who haven't heard of it, Phil Hazelberg, the Lineage inventor, went and wrote a thing called Grenchman that was an OCaml binary CLI client that spoke in REPL to a Lineage running in a server remotely, and it mostly worked. But it had some limitations around the way that Lineage's tasks were all written to expect being able to like sys-exit the entire process and some other stuff like that wasn't great. And so that didn't fit my needs for this. And it certainly brought along with it the baggage of the Lineage ecosystem, rather than being a very simple layer on top of tools.deps, which is a fairly simple layer. Not that I haven't been a happy Lineage user for the last 7 years of my life, just I'm building a new thing here. So as far as future work goes, Katamari right now is not in use at Funding Circle because it doesn't have a way to boot a REPL yet. It doesn't have a way to run your tests yet. And these are like both obvious defects that can both be easily remediated. Frankly, I've been losing sleep over getting this thing even to the presentation level, so it just hasn't happened yet. Hence why I'm sick. The other thing here is there's more target types that are needed. So the big one for me is Docker. It turns out that Uber jars are an absolutely dreadful way to build Docker images because of the way the Docker's file system works as a set of layers of tarballs that get unzipped. It's much more efficient in terms of being able to reuse layers from previous builds, to copy in your dependent jars one at a time, and then say copy your entire source tree as a layer, or some other combination of things that more accurately reflects where the change in your process is going to happen. It would be very easy because you can tell Docker to take its Docker file from standard input to go write a Katamari task that shells out to Docker and like meta programs the build script that Docker runs to dynamically start copying stuff in. Again, easy future work that will probably be needed for me to deploy it here, just hasn't been done yet. The major thing is, you'll notice if we go back to the roll file, example roll file, that all of these dependent versions are nil. This is because what's happening here is they're pulling their versions from the override dependencies and the default dependencies present, computed either from the inputs, all the things that get built in the tools.deps, in the role graph, or they're pulling them from the global version pinnings. So here, if we edit the deps cat, let's see, cat resolve. I think it's this one. Nope, other one. Yeah, so here we're injecting the global default dependency of Clojure at 190. That gets pulled in and clobbers whatever your pinned Clojure version is, which is why the dep to nil works. This is actually default tools.deps behavior. It just doesn't have a good pattern right now because there's no way to inject additional deps files when you build your deps manifest. This is one of the things that Ein patched, and was one of the reasons that Ein exists as a script instead of just being tools.deps. So the real problem here is that because this is, this is a file that's not depended on directly by any build target. It is implicit magical state that gets pulled in and is not properly included right now in your target fingerprinting. So if you went and bumped this to 010, 110 alpha 3 or whatever the current, I guess we went from RC1 to alpha 7 or something, then that would not properly envelop the build graph right now. This is a known bug that needs to be remediated by pulling your Maven dependencies out and doing this resolution step in the rule prep time rather than doing it dynamically when you build the class path. Question?
Stuff in your roll file overrides this, or this overrides your roll file?
This overrides your roll file.
Overrides your roll
on purpose, yes.
Wow.
The intent here is that you have a way to say, I depend on Kafka. For this entire repo, I have one Kafka version. For Clojure, for this entire repo, I have one Kafka. I have one Clojure version. I have one one environment version. I have one version of this thing. I want to be able to rapidly just say, I'm going to lockstep all my dependencies. I'm going to lockstep all my source artifacts. All of it just goes bam, 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 one place, one consistent behavior globally. Sorry?
Change all the OpenSSL.
Sure. If you wanted to go, manage your OpenSSL version or something like that. Yeah, that's kind of all I got. So as of right now, Katamari is open source, as is Ein, in fact. It's on GitHub at artem/Katamari. The latest release is 0.05, which you just saw run here on stage. It is as stable as 0.05 suggests. I'm working on it. Oh, I'm not sharing anymore. Sorry. I guess Zoom kicked me out. Whatever. It is my intent to maintain this as actively as my job permits. I'm going to be dialing it back a little bit from my previous rate and time of output, given that shipping 4M code is not a sustainable thing. But it is a thing that I think fills an interesting niche in the ecosystem and composes well with existing tools and the use intent of the existing tools. And I hope sees some progress. So thanks also for coming. Question?
So you wanted to add REPL and test.
Yes.
It seems like a thing that does one thing and does it well. Why should REPL and test do different things?
So the problem is that test, and especially incremental test, requires exactly the same state data that incremental build requires. And so you really do want them in one place, or at least it's natural to try and start tying your build to your change detection machinery, your retest your change detection machinery. Because the question I need to be able to ask, this is the thing that Pants lets you do, is you say, test changed since origin master, right? And what that does is it goes and it introspects the Git history between where you are and origin master, looks at the files, looks at your file system, looks at the roll file or the build files for Pants, figures out what targets are impacted by the file system changes that are present since the ref you mentioned, and then goes and runs only the tests that are transitively impacted by that change set. And that is essential to implementing a proper minimal CI, like incremental CI test workflow, which is the core deliverable of this system. So you could go start trying to factor that out. It turns out one of the interesting results of the build systems a la carte paper is that there is a way to, using for Haskell some higher order parameterization stuff, get a incremental or get the change detector for free given your build algorithm. So you could have a thing where you just do the change detection, have a change detect output, and then that's a thing that you go incrementally build and type that all together.
Change set.
Sorry? Yeah, I mean, sure.
Like the test and the REPL could be separate things.
And they will be separate things in that they are separate server level extensions that have nothing to do with the actual rolling machinery. They will be just clients of it through the same extensions API. So as far as I'm concerned, they are just composed tools, but I see no reason to go break them out into, say, Unix style tools that will only have the same, JVM startup woes. And I certainly have no incentive to go kind of write them as bash scripts using JQ to parse Katamari's JSON responses when I could just leverage Clojure and the existing Katamari protocol for that. Okay.
You seem to be built deep into the subject. Can you kind of on the latest, can you talk about why people like Haskell especially are big on Nix? It's so.
Oh, so
why is it so historically difficult to get integration with JVM? And JVM ecosystem does not accept Nix and Geeks.
Yeah, so with Nix and Gix, or Gix, I don't know what the pronunciation is. For those of you who haven't heard of these projects before, they are attempts to build operating systems where you can co-host multiple versions of libraries using content addressing. So the same way that Katamari maintains a build cache of all these different things at different versions simultaneously, Gix and Nix are entire operating systems based on doing this. So you'd have multiple versions of libc, multiple versions of OpenSSL. Something like this, yeah. The problem is that because the notion here is that maintaining compatibility is really hard, and talking about binary compatibility is almost impossible. So it's easier to just let all your packages have their own pinnings and co-host multiple versions of your binary libraries than it is to really figure out the compatibility properly, like, you know, in Arch or on, sorry, no, on Arch or what's the other, like, oh, on Arch or BSD or like some other more aggressive, Gentoo, that's the one I was looking for, like Unix distribution, you'll have these like single global libc that gets bumped a lot, and it's not uncommon to see like libc compatibility problems in your applications as a result, depending on how well your libc is maintained, for instance, or some other transitive library. Gix sort of solves this problem by saying, okay, well, we're just going to let everything have its own libc if it so requires, and just not even solve that problem. So the JVM, for the most part, just doesn't have this problem because jars are already like content address sandboxing, and multi-jar file based class paths already give you exactly the same, like, you know, no, we don't have to have a single global version of this thing behavior that Nix and Gix and all these other things have to go invent, because they're solving that problem for Unix, like Unix systems that traditionally have not had that same sort of multi-version packaging or sandboxing support. So, yep. On that note, I am out of time. Need to literally sprint to the airport. So, thank you all so much for coming, and I hope that you enjoyed this, and I hope you check out Katamari, or at least help me kind of push the ball up the hill for a more useful state.
We really appreciate you doing this and not canceling.
Oh,
You were sick.
Thanks.
thanks.